Hello and welcome to the Essentials of Algebra 1. I'm Stuart Harrington, your guide through this series of topics from high school level Algebra 1. This is module number 6 of this series, and our focus in this segment is writing linear equations in two variables. So let's get started. We study mathematics in order to apply mathematical principles to our everyday lives. Math is everywhere. If someone tells you that they never use math in their daily life, they might not be lying to you. They are probably just avoiding using math at all costs. If you run a home or a company, or you work for someone who runs any type of business, you are responsible for managing income and costs. The flow of money involves the use of formulas that track variables, placing those variables into equations or other mathematical models that provide information to the owner. In this module, you will practice translating problem scenarios into mathematical formulas. But don't worry, the formulas we work with in our protected world of Algebra 1 are beginning level linear equations that have one input, an x value, and one output, a y value. In this module, you'll see how to write linear equations when given a table of values, a graph, or a verbal description. A few things to review. First, every line has a name. We call the name of a line its linear equation. In order to write the equation of a line, you must know the slope of the line and a point that is on the line. There are no exceptions to that rule. Now, there are three forms of linear equations. The two that we will use today are the slope-intercept form and the point-slope form. This is your slope-intercept form. You should be familiar with it, y equals mx plus b. Remember that in this format, the variable m represents the slope of the line. Letter b is the y-intercept. This is the point where the line crosses the y-axis. It also represents the beginning point or the baseline value or a flat fee that you might be charged in a particular situation. If you know the slope and you know the y-intercept, always use this form to write your equation. Here is the model for the point-slope form. You can read it, y minus y sub 1 equals m times x minus x sub 1. Now this may sound a little confusing, but let's look at its parts. M is again the slope. The x1 and y1 is a point that you know is on the line. You use this form when you know the slope, but you don't know the y-intercept. You know a point on the line, it's just not that y-intercept. A couple of additional comments about the slope. Remember that the slope of the line is the rate of change. It's a unit rate, or it's an amount of gradual increase or decrease. The slope is a ratio. It compares the change of the y values to the change of the x values. So if you don't know the slope, you'll need to use 2 points to help you calculate that slope. And here is the formula for that slope equation. y2 minus y1 over x2 minus x1. Let's work through this example. Write the equation of the line given the slope is -2 and the y-intercept is 6. We know our slope, we know our y-intercept. We need to recall that when we know these two pieces of information, we are going to use the slope-intercept form. Now what was that? Y is equal to mx plus b. Recall what that m stands for. Recall what the b stands for. As you read through this problem, we want to know what is the slope, what is the y-intercept. Slope is going to be the m value. The y-intercept will be substituted for the b value. Very simply, our answer is going to be y equals -2 times x plus 6. That's all there is to it. Substitute your slope in for m and substitute your y-intercept in for the b value. Let's take a look at another one. Read this problem with me. Write the equation of the line that contains the points 6, 5, and 3, 1. Are we given the slope? No, we're not. Are we told the y-intercept? Not given that either. So what do? Can't really use the slope-intercept form of the equation, so we've got to implement the other equation that we talked about a few minutes ago, and that is the point-slope form. Let's put it back up on the screen so that we can see what it looks like, because it's not as common as the slope-intercept form. Here is our point-slope form. Let's take a look at some important components of it. First of all, notice that this y value here and this x value here, the graphic says don't touch these, because those are x and y coordinates that belong on the line. So you don't need to mess with those. You just leave them in the formula. The next thing to pay attention to is this x1 and this y1. Those are the x and y coordinates of a point that you know is on the line. So keep that in the back of your mind that you are going to make a substitution for the y1 and x1 numbers. And finally, look at this m value here. That's our old friend, the m value, which means slope. Now, we do not know the slope yet. How are we going to figure that out, Mr. Harrington? Well, let's take a look at that right now. Here is your equation for the slope. If you know 2 points on the line, you are going to be able to figure out the change of y and the change of x for that line. Let's take a look at this problem and see how we do that. Our 2 points are 6, 5, and 3, 1. One way to look at this is to remember we're looking for the change of y to the change of x. Well, how do we change from 5 to 1? Well, that goes down by 4. So we're going to call that -4. How do we go from 6 to 3? Well, we go down 3. So that's going to be -3. If it were going up, we would say positive. But we're going down, so we're going to say negative. -4 divided by -3, a negative divided by a negative is going to turn into a positive. So we're going to put a little plus sign there. 4 over 3 does not reduce, and it doesn't divide out evenly. So we're simply going to leave it as 4 over 3. That's going to be our slope. Now let's make use of the formula. Our formula says to take the y value of the second point minus the y value of the first point. That means we're going to take 1 minus 5 over 3 minus 6. And look what that does. 1 minus 5, yep, there's our -4. 3 minus 6, yep, there's our -3. We still come up with this negative divided by a negative, which is a positive, and 4 over 3 still doesn't reduce, still doesn't divide out evenly, and so we get that same number. Whether you use it as sort of a concept base of how did this y value change into that y value, and how did the x change into that x, or if you literally plug numbers into the formula, you're still going to get the same answer for your slope. So we have now come up with our slope as positive 4 over 3. What do we do now? We plug things into our point slope form. Remember, we are not going to touch this x and that y. We are going to substitute a y1 and an x1 based on a point that we know. Well, which point do we want to use? It doesn't matter. You can use the 6, 5, or you can use the 3, 1. Let's use the 6, 5 for right now. I'm going to make my substitution. We're going to start off with y minus y1. Well, here's that number. That's going to be 5, is equal to m, that's our 4/3, times x minus x1, x minus 6. That's our linear equation written in point-slope form. What if I wanted to use the other point? Here's how it's going to look. This is going to be your y value. This will be your x value. So we'll have y minus 1 is equal to 4/3 times x minus 3. You say, Mr. Harrington, that looks very different. And it does. It will look different depending on which points you use. If you use algebra on those two equations to convert them into a slope-intercept form or the standard form, then the equations will look identical to each other. So don't be concerned that the point-slope form doesn't quite look like you think it might should. All right, let's work another problem. Read this problem with me. A plumber charges $150 an hour, but also charges $75 just to visit your home. Write the equation for the total cost for a plumbing job at your house. On this particular problem, we are not really told anything other than we have $150 an hour and we've got a $75 visit charge to come out to our house. How do we translate that into a linear equation? Here's how we do it. Remember that we talked about slope representing a rate of change. The hourly rate is $150 an hour. You know from your own work experience that the number of hours worked is going to impact the rate that you are paid. Consequently, $150 for 1 hour, $150 an hour for 2 hours would result in different amounts of money that you earn. So that is going to be our slope number. M is equal to $150. We also mentioned a moment ago that the y-intercept, in mathematical terms, it represents where the line crosses the y-axis. When x is equal to 0, that is the y-intercept in mathematical definitions. In real-life applications, the y-intercept will be flat rates that you are charged immediately just to begin work, such as what we have right here. Before the clock starts ticking on your hourly rate of $150, you are starting off owing $75 just for the plumber to come out to your house. So the y-intercept is going to be $75. So $150 is the slope, $75 is the y-intercept. Which equation should we use? We know the slope, we know the y-intercept. That should set off a bell in your head that says I need to use the slope-intercept form. So what is our answer going to be? We're going to start off looking at this model, y equals mx plus b. We're going to say that y is equal to the slope, that's 150, times x, which represents the number of hours that we're going to work, plus 75, which represents the initial cost, the flat fee for just showing up at the house. Okay. So maybe to write it in a little more meaningful way, we could say that the cost is equal to 150 times h, which represents the number of hours worked, plus 75. Okay, let's take a look at another problem. An electronics company manufactures 1,000 microchips and earns a $10 profit per chip. When it manufactures 5,000 microchips, it earns a $30 profit per chip. Assuming this is a linear function, write the equation. So this question provides 2 points. The points 1,000, 10, and the point 5,000, 30. It doesn't tell us anything about slope. It doesn't mention anything about an initial cost. So we don't know a slope. We don't know a y-intercept. So what are we going to do? Can't use slope-intercept form? We've got the point-slope form. So let's bring it back up just to make sure we remember what that looks like. Remember, there are parts of it that we do not touch. We don't touch this y right here, and we don't touch that x. We are going to make a substitution for the two y and x sub 1s, and we're going to make a substitution for the slope. First things first, we don't know the slope. How are we going to get that? We are going to use the ratio, the change of the y values compared to the change of x. What does that mean for this problem? What do the y values do? The y values go from 10 up to 30. That's a change of 20. The x values go from 1,000 up to 5,000. That's a change of 4,000. Now this is a slope that can be reduced. I can divide by 10, which will be 2 over 400. And then both of those terms, both the numerator and the denominator, divide by 2. So 1 over 200, that is going to be my slope. Now it's time to go to the point-slope form. Select one of our points to use with the slope that we have found and make our substitutions. Follow along. Let's select this first point here. We'll use it. Our formula begins with y minus y sub 1. That's going to look like this. Y minus y sub 1. That's going to be 10. That's the y value of the point we chose. That's going to be equal to the slope, which we just determined was 1 over 200, multiplied by x minus the x of our point. That's going to be x minus 1,000. In terms of point-slope form, we are done. What if we selected the other point? Then we would have the following. Y minus 30 equals 1 over 200 times x minus 5,000. That would be your answer. At the risk of being repetitive, these two equations don't look like each other. They look like they're different. They are actually the same. If we were to simplify and collect all of our terms together and rewrite this in, say, for example, slope-intercept form or standard form, then these two equations you would see look exactly the same. But for now, all we're wanting to do is see if we can get it into a linear equation. And the point-slope form is the one we're going to use here. Okay? Now, we have worked several problems involving translating verbal information into mathematical information. If you remember from our objective, we were also going to look at some tables and look at some graphs. So let's work a couple of those right now. Here's a table of values. This is a very mathematical type of problem, but our object is the same. Generate the linear equation that names the line described by these points. As I look at this, I am not told a slope. I am not told a y-intercept. And so I have to make this conversion using point-slope form, just like we've done on the last couple of problems. So let's review that point-slope form just to be sure we remember what it is. Now on this version of the point-slope form, we don't have all the little notes about what to leave alone and that sort of thing. But let's remember how that works. We are not going to make substitutions for that y and that x. We are going to make a substitution for the y1 and the x1, and we are also going to make a substitution for the m value. We actually, in this problem, have 3 points that we can select. Again, it doesn't matter which of the 3 we choose. We can just pick whichever one we want to. However, we also don't know the slope, and we need to figure that out, which means we need to bring in that slope formula to help us with that. Let's put it to work. I only need 2 points to figure out the slope. So I'm going to select this point here and this point here. This will be point number 1 and this will be point number 2. What is the change between 7 and 10? It's a positive 3. What does the x change from 1 to 2? That's a positive 1. So the slope, just looking at the change in y divided by the change in x, is very simply 3 over 1, which is equal to 3. That's our slope. Say, Mr. Harrington, you're not using the formula. Okay, well, let's use the formula then. The y of the second point, that's 10, minus the y value of the first point, 7, over the x of the second point, 2, minus the x of the first point, 1. 10 minus 7 is 3. 2 minus 1 is 1. And look at that. We still get our slope of 3. So, conceptually, how much did the y value change? How much did the x value change? Write it in a ratio. Change of y over the change of x. Just pay attention. If you're going up, it's a positive number. If you're going down, it's a negative number. If that makes you uncomfortable, use the slope formula. Not a problem at all. Now let's get rid of some of this work that's on the board because we need a little bit more room to calculate the actual linear equation. Here we are. Let's remind ourselves what our slope was equal to. Slope was equal to 3. Now we need to select a point. Which point should we use? It doesn't matter. Let's just use the first one. This one right here. Y, remember we don't change that one, minus the y value of your point, 7, is equal to m, which is our slope, times x minus the x value of our point. That's all there is to it. You're just making the substitution. The x and y value out of one of your points and the slope that you found. If you want to use the other 2 points, how's that going to look different? Y minus 10 is equal to 3 times x minus 2. Or if you use the third point, y minus 13 is equal to 3 times x minus 3. So those are alternative answers that would be correct as well. We will not work those out. We will not simplify those to see and verify that they are the same. But we have a slope, we have a point, and we use the point slope form to come up with the answer. So there is an example of how you would work a problem where the data is provided to you in a table. Now let's take a look at what one would look like if the data is provided to you in simply a graph, a picture of the scenario. Look at this picture of this data. It's a graph. What are we told? We are given no points. We do not know any of the points, so we're going to have to inspect the graph to figure out what points might be. We are shown that the line crosses the y-axis. So for the first time in a while, we actually can figure out the y-intercept. How am I going to do that? I'm going to simply look at the graph and realize that it crosses the y-axis right here. That is at the point 2. So B is going to be equal to 2. How am I going to figure out the slope? I'm going to inspect the graph a little bit more closely and realize that another clean point is right here. By clean point, I mean it goes directly across the crosshairs of the coordinate plane. That's an easy point to name. The name of that point is very simply the point 3, 4. I could also go back the other direction, and here is another clean point. It is -3, 0. Now I've got 3 points because I actually know this one as well. It's the point 0, 2. So I've got all of these points, and I just simply need to find the slope. Now I can do it 2 different ways. One is to use the formula. One is to just physically inspect what was the change in y over the change in x. Or the easiest way is just to count the spaces. Watch this. Remember, we're looking for the change of the y values, delta y over delta x. And so if I go look at the point 0, 2, it's on this level right here. And I'm going to the next point, which is on this level right here. So how far did we go? We went 2, and it went up 2. So that's going to be a positive 2. Now what did our x values do? The x value of 0, 2 is right here. The x value of the other point is here. We're going right to left. How far? 1, 2, 3. I'm just counting spaces. So the slope is simply 2/3. So now I have the slope. I have this y-intercept, which is the point 0, 2, in case somebody needs to ask what is the exact coordinate of that y-intercept. What equation am I going to use? I don't need the point slope form. Get that off the screen. This is the equation that I need. Y equals mx plus b. Don't need the point slope form because I have the information in hand already. I'm simply going to make my substitutions. Y is equal to m, which was 2/3, times x plus the b value. The b value is positive 2, so we'll put a plus 2 right there. There we have our answer to that question. We have now demonstrated how to write linear equations from verbal descriptions, from a table, and from a graph. Let's remember a couple of things before we dismiss you from this video. First, every line has a name. We call the name of the line its equation. In this module, we use the slope-intercept form of equations and the point-slope form of equations. If you know the y-intercept and you know the slope, then you want to use the slope-intercept form. Just remember that the y and the x, you don't change those. M is the slope and b is the y-intercept. If you don't know the y-intercept, then you're probably going to need to use the point-slope form. You do have to know a point, so when you're given that point, use the slope that you're provided and write the equation, making your substitutions as we discussed. What if you're not told the slope? Then you will have been told a couple of points. Use those 2 points to calculate the slope, and then use one of those points to make the substitution into the point-slope form. Also remember that in those verbal problems, when you're solving those, the y-intercept is going to be the quantity that is the starting point. It's an initial amount, or it's a flat fee. Remember, we had the problem where the plumber had a flat fee just to show up at the house. Did not count the slope, which was the $150 per hour. It was just $75 just to drive his truck over to your house. So flat fees, initial amounts, all of those kinds of things are going to be your y-intercept. And finally, that slope is going to be a rate of change. It might be a unit rate. The unit rate was $150 per hour on that one particular problem we solved. Okay, and it could also be just like a gradual increase or something. Read the problem and decode what the rate of change needs to be. So that will conclude our work in this video. You are now ready to watch the second video, which is the problem set, where we just work and solve some problems. Once you have completed that, you will then be ready for the short assessment over this module number 6. Thanks for watching, and we'll see you next time.